Hi, the title of my work is Unbalanced Functions of Sexual Communication Leads to Reproductive Interference in Two Syntopic Scorpion Species, and was conducted in Argentina under the direction of Alfredo Peretti and Camilo Mattoni from Universidad de Córdoba, with the collaboration of Luis Ernesto Costa-Schmidt from the Universidad Federal de Pelotas. Sexual communication in mate choice involves three non-mutually exclusive functions: mate recognition, mate assessment, and species recognition. These functions could interact in multiple ways, stating mate choice as a continuous and complex process that comprehends a delicate balance between natural selection and sexual selection. While natural selection would improve species recognition, sexual selection would promote both mate recognition and assessment. For example, females of this fish species use body size as a sexual selection cue, preferring large heterospecific to small conspecifics. In this case, body size is a conflicting cue in the mate choice process, resulting in an imbalance between the functions of sexual communication. This imbalance can also generate a pattern of reproductive interference. This process arises when individuals of different species sexually interact during reproduction, with one or both actors suffering a fitness cost. Heterospecific interactions are widely spread in nature. For example, in this case, you can see two different genera of frogs in Amplexus. However, closely related species are the most susceptible to interference, because signal misinterpretation increases with the overlap of the communication channels of the interacting species. Here, multiple species of Abronatus jumping spiders court interspecifically. One type of sexual communication is chemical signaling. Pheromones may carry information for mate recognition and mate assessment. Then, sexual selection becomes a leading evolutionary driving force upon them. If pheromone emission by females is costly, we expect a condition-dependent expression, making the signals reliable indicators of female quality. In this way, males base their mate choice in chemical cues. In this framework, the male mating success depends strongly on its ability to locate and assess potential mates. In particular, in scramble competition scenarios, these skills are extremely important, so they may depend on male condition. Regarding the species recognition function, pheromones' performance as a premating isolation mechanism is proportional to their chemical specificity. In sympatric zone, these signals may reinforce species recognition to avoid reproductive interference. Pheromone signaling has been extensively studied in arthropods like insects and spiders, but the studies that explore the evolutionary importance of these signals in scorpions are scarce. Scorpions have a broad sensory repertoire where chemical cues are crucial in reproductive activities. We assessed the functions of sexual communication in two closely related scorpion species: Urophonius achalensis, from now on the red species, and Urophonius brachycentrus, the blue species. These scorpions have sympatric distribution with synchronic reproduction. They are active during winter and inhabit mountain ridges of central Argentina, sharing the same habitat requirements and life history traits. Though females of the red species are 15% larger than those of the blue species. Males of this species search for receptive females with a scramble competition dynamic. Males are polygenic and females are monandric. In addition, there are records on the occurrence of interspecific mating and sexual attraction between these species. These features make these scorpions excellent species to address the hypothesis that the improvement of chemical communication for sexually selected functions results in the disruption of naturally selected functions. To test this hypothesis, we analyzed volatile pheromones using a glass olfactometer with 3 branches. At the end of a central branch, a chamber contains the focal male. In 2 lateral chambers, we arrange the females as a source of chemical stimuli. Some trials present the female versus an empty branch. Others present a conspecific female versus an heterospecific one. we generated a stream of air with a fan placed at the end of each lateral branch, and we digitally recorded the male activity for 30 minutes. Then we analyzed the first lateral branch chosen by the male, the time spent in each lateral branch, and the latency to choose some lateral branch. In all statistic models, we included the body condition of individuals estimated on the residuals of the regression between the size and weight. Moving to the results, what have we found regarding male recognition? In these graphs, you can observe the percentages of fair choice of males, and we found that in both species the males are first attracted toward the conspecific female, in the red species and in the blue species. Also, you can see in these box plots the time spent in the branches of the olfactometer by the males. We found the same pattern. Both species spend more time in the conspecific branch than in the empty branch. Analyzing the mate assessment, we found an effect of conspecific female body condition on the time spent in the branch of that female. Males of both species spend more time in the branch of conspecific with higher body condition. Moreover, the males were faster in their choices with higher condition conspecific females. When evaluating the function of species recognition, we found that both species choose in equal proportion the conspecific and the heterospecific female. But when we observe these plots on the time spent by males in each branch, we found that while the red males spend the same time on both branches, the blue males spend less time on the conspecific than the heterospecific branch. So, we found that males of both species use volatile pheromones for male recognition. Also, males seem to assess the female quality by sex pheromones. Once the males recognize a potential mate in a close range, they stay in that branch. These results provide evidence that male choice is mediated by chemical cues in both species. However, we didn't find a relation between males' body condition and searchability as predicted in systems with scramble competition. In the future, we will evaluate other variables that may better reflect the male skills for locating mates. Our results do not support a role for pheromones in species recognition and demonstrate the existence of reproductive interference. Highly conserved sex pheromones could explain the lack of species recognition in this case. Laboratory observation of heterospecific mating support the notion of a lack of reproductive barrier, at least in a precopulatory level. Maybe because the red females are in better condition than the blue females, the blue males would be more susceptible to chemical confusion than the red ones. So, the mate quality effect would be dominant, conflicting with the species recognition function in the blue species. This unbalance between the functions of sexual communication could lead to reproductive interference. This can imply different costs associated with increased risk of predation by females of the other species, as you can see in this photograph. Furthermore, if the mating process continues, there may be cost to the male in unsuccessful courtship, even reaching the deposition of spermatophores, involving a high energy investment because have a complex and chitinous structure, with sperm and seminal fluid. Also, the females should pay high cost, because after mating, they are plugged by the males so they can remate. This is a plug blocking the female genital opening. We show that males of scorpions use chemical signals for different functions in the mate choice process, evidencing an imbalance between these functions. In this case, sexual selection functions are predominant over species recognition. This leads to a pattern of reproductive interference that could have serious costs in the fitness of males and females of this species. Thank you for listening. I wanted to thank the organization of the Animal Behavior Meeting for giving me the opportunity to participate in this symposium. Also, thanks to the finding sources of this work, to all the people who helped me in the field trips, and to my colleagues in the laboratory.